There's a moment in the future of the universe that no human will ever witness, a moment when the final star quietly fades out. No explosion, no dramatic collapse, just darkness. And here's the question that keeps physicists awake at night. What actually happens after the last star dies? Not just it gets dark, but what happens to time, to matter, to reality itself? Because if stars are the engines of the universe, then what's left when the engine stops? And even stranger, will anything still exist to notice? Or does the universe simply forget itself? These aren't science fiction questions. They are real. And the answers are far more unsettling than you might expect. Tonight, we're going to follow the universe all the way to its final chapter. Not billions, not trillions, but unimaginable stretches of time beyond anything the human mind was built to grasp. And along the way, we'll uncover three mysteries that scientists still haven't fully solved. What is the true fate of matter when everything decays? Can anything survive in a universe without energy? And most haunting of all, does time itself eventually come to an end? We won't answer them right away, but piece by piece, we'll get closer. So dim the lights, get comfortable, and let's begin at the edge of eternity. Right now, the universe is still alive. Stars are being born, galaxies are colliding, light is everywhere. But even now, the ending has already begun. Every star you see in the night sky is running on borrowed time. Stars shine because they burn fuel hydrogen, slowly fusing into helium. It's like a cosmic candle, incredibly bright, but not infinite. And just like any flame, eventually it runs out. Some stars die violently, exploding as supernovae. Others fade gently, shrinking into white dwarfs. But no matter how they end, they all share the same fate. They stop shining. Now here's something most people don't realize: the universe is not replacing stars as fast as it used to. In fact, star formation peaked billions of years ago. We're living in what scientists call a declining universe. Less gas, fewer new stars, more darkness creeping in, which means, in a very real sense, the universe is slowly running out of light. And yet, this is only the beginning of the story. Because even after the last star forms, there will still be light for a while, but not forever. Before we go further, let me ask you something. If you're enjoying this journey into the far future of the universe, you can support it quietly by liking the video or subscribing. Not because it helps me, but because it tells the algorithm that quiet, thoughtful science like this is still worth exploring. And honestly, that's kind of beautiful. Now, let's move forward. Imagine a time, trillions of years from now, the last new star has already formed. No more stellar nurseries, no more glowing clouds of gas, just aging stars, slowly burning out. This era is called the stelliferous era, the age of stars, and it ends, not with a bang, but with a whisper. One by one, the stars begin to disappear. Red dwarfs, the smallest stars, last the longest. They burn slowly, like embers that refuse to die. Some of them could shine for up to 10 trillion years, but even they cannot last forever. Eventually, even the most stubborn stars fade into darkness. And when the final red dwarf goes out, the universe enters A completely new phase. A phase so strange it barely resembles the universe we know. Here's where things start to feel unsettling. Because after the last star dies, there is no more visible light. No sunsets, no glowing galaxies, no way to see anything. The universe becomes almost entirely black, but not empty. Not yet. What remains are the leftovers of stars, white dwarfs, neutron stars, black holes. These are the corpses of a once luminous universe, cold, dense, silent, and drifting farther apart every second, because even now space itself is expanding. Galaxies are moving away from each other faster and faster, eventually so far apart that no galaxy can see another. Imagine standing in a universe where your entire observable sky contains nothing. Not because nothing exists, but because everything else is too far away to ever be seen again. Now, here's a thought that changes everything. If you were born in that future, you would have no idea the universe was ever full of stars, no evidence, no light, no cosmic history. To you, the universe would appear empty and eternal, which raises a strange question. Is a universe without memory still the same universe, or has it become something else entirely? And we're still not at the end, because even these stellar remnants don't last forever. White dwarfs will cool, becoming black dwarfs. Neutron stars will slowly decay. Even black holes, the most extreme objects we know, are not eternal. But we'll come back to that, because the real mystery isn't just what disappears, it's what remains. Here's the part that tends to surprise people. After the last star dies, the universe doesn't suddenly end. In fact, it continues for incomprehensible lengths of time. Longer than all of human history, longer than all stars combined, longer than you can meaningfully imagine. And during that time, strange, quiet processes begin to dominate. Atoms slowly breaking apart, particles drifting through endless space, rare, random interactions happening once every trillion years. The universe becomes less like a place and more like a slow, fading echo. But now we arrive at a deeper mystery, because something very important is still happening. Even in this dark universe, time is still moving. Seconds still pass. Events still unfold, even if nothing is watching. Which leads us to our first big unanswered question. What does time mean in a universe and where nothing changes? If there are no stars, no light, no events we can measure, is time still real? Or does it become something else entirely? We won't answer that just yet, but hold on to it, because it becomes crucial later. And here's the promise. By the time we reach the end of this journey, you'll understand. Not just what happens after the last star dies, but whether anything can truly last forever, and whether the universe in its final state is silent or something far stranger. For now, we've only reached the edge of darkness. In the next part, we step into a universe without stars, without light, but not without mystery. Because what happens next is where physics itself starts to break down. The universe is now completely dark. No stars, no galaxies lighting the sky, no familiar points of reference, just cold remnants drifting through an expanding void. And yet, something is still happening, something slow, almost imperceptible, but deeply important. Because even in total darkness, the universe is not at rest. Imagine standing in this future. You float in space, surrounded by nothing visible, no sunrise, no movement you can easily detect. At first, it might feel like time has stopped, but it hasn't. And that's where things begin to get strange. Here's the unsettling truth. Even after the last star dies, the universe is still changing, just incredibly slowly. So slowly that entire civilizations, if they existed, would rise and fall without noticing any difference at all. This era is sometimes called the Degenerate Era. Not because it's broken, but because everything that once produced energy is gone. No fusion, no new light, only leftovers. Let's take a closer look at what's left. White dwarfs. These are the burned-out cores of stars like our Sun. They're incredibly dense. A single teaspoon of white dwarf material would weigh as much as a car. But more importantly, they're hot at first. Then, slowly, they cool. Over trillions upon trillions of years, they fade from white to red to black, eventually becoming something called black dwarfs. Completely cold, completely dark. And here's the twist. The universe isn't old enough yet for even one black dwarf to exist, not a single one. Which means when the last star dies, a completely new kind of object will begin to appear for the first time. Now, think about that. A universe where the most common stars are no longer shining. Just cold, invisible embers drifting in space. But white dwarfs aren't alone. There are also neutron stars. These are even stranger. They're so dense that atoms themselves collapse. Protons and electrons merge, forming a giant sphere made almost entirely of neutrons. If you dropped a marshmallow onto a neutron star, it would hit the surface and instantly compress into something smaller than a grain of sand. And yet, even these extreme objects don't last forever. Over unimaginable timescales, they too begin to change. Now, here's where our first loop deepens. We asked earlier, what is the true fate of matter when everything decays? We're not answering it yet, but here's a clue. Matter may not be as permanent as it feels, because according to some theories in physics, even the building blocks of atoms, protons themselves, might not last forever. This idea is called proton decay. It hasn't been observed yet, but if it's real, then everything made of atoms, you, me, planets, stars, even these stellar remnants will eventually fall apart. Not explode, not collapse, just slowly dissolve. Picture a black dwarf, cold, silent, drifting in darkness over an almost incomprehensible span of time. Its atoms begin to break down. One proton disappears, then another, until eventually the entire object is gone. Not destroyed in a dramatic way, just faded out of existence. And this raises a second big question. If matter itself can disappear, what is the universe actually made of at the end? Hold on to that. We'll come back to it. Now, let's zoom out even further, because individual objects aren't the only thing changing. The structure of the universe itself is evolving. Remember how space is expanding? That hasn't stopped. In fact, it's accelerating. Galaxies are moving away from each other faster and faster. By this point in the future, everything is incredibly far apart. Distances so vast that even light traveling at the fastest speed possible can't bridge the gap anymore. Imagine sending a signal, a beam of light, traveling outward forever, but the space between you and your target is stretching faster than the light can travel, so the signal never arrives. Not because it slows down, but because the destination keeps moving away, faster than it can catch up. This leads to a haunting realization. The universe becomes permanently disconnected, not just empty, but isolated, each remaining object alone in its own observable bubble. No communication, no interaction, just silence. Now pause for a second, because this connects to our third question. Can anything survive in a universe without energy? At first glance, it seems impossible. Life as we know it depends on energy. Stars provide that energy. Without them, everything should stop. But here's where things get interesting. Even in a cold, dark universe, there are still tiny, rare sources of energy. Gravitational interactions, quantum fluctuations, occasional collisions between remnants, they're incredibly weak, incredibly rare, but not zero, which means, in theory, something could still happen, very, very slowly. Imagine two black dwarfs drifting through the space for trillions upon trillions of years. They never meet. Then by pure chance, they pass close enough for gravity to pull them together. They collide, and for a brief moment, energy is released. Heat, light, a tiny flash, in an otherwise eternal darkness, a universe where events still happen, but so rarely that each one feels like a miracle. And now we arrive at something even stranger, because as everything spreads out, and matter slowly disappears, and energy becomes scarce, the universe begins to approach a state called heat death. Heat death doesn't mean the universe is hot, it means the opposite. It means energy is perfectly spread out, no gradients, no differences, and without differences, nothing can happen. Think of it like this. Imagine a cup of coffee. At first, it's hot. The heat flows into the cooler air. Eventually, everything reaches the same temperature. At that point, no more heat flows, no more change. Now, apply that idea to the entire universe. When everything is the same, when there are no differences left, no energy to transfer, no processes to drive, the universe becomes still. Which brings us back to our earlier question, what does time mean in a universe where nothing changes? Because if nothing happens, how do you measure time? What does a second even mean when there's no event to mark it? We're getting close to something profound here, but not quite there yet. Because before the universe reaches complete stillness, there's one more player in the story, one that refuses to follow the rules, one that survives longer than anything else: black holes. And here's the promise. In the next part, we're going to follow the last surviving objects in the universe, and what they do will completely change how you think about endings. Because black holes don't just sit there, they do something unexpected. Something that slowly, quietly rewrites the fate of the entire cosmos. And hidden inside that process might be the answer to our biggest question yet. Does anything truly last forever? The universe is now older than anything we can truly imagine. No stars, no light, no warmth, only darkness, and the last surviving giants, black holes. At first glance, black holes seem like the perfect survivors. They don't need fuel. They don't shine. They don't fade like stars. They simply exist, endlessly consuming anything that comes too close. And for a long time, scientists believed exactly that black holes might be the final, eternal objects of the universe, the last things left, after everything else disappears. But that assumption turned out to be wrong. here's the twist that changes everything. Black holes are not truly black, and they are not eternal. This idea comes from one of the most surprising discoveries in modern physics, a discovery made by Stephen Hawking. And it reveals something deeply unsettling about the nature of reality. To understand it, we need to step into the smallest scales imaginable, into the quantum world, even in what we call empty space. Space is not actually empty. It's constantly fluctuating. Tiny particles appear and disappear all the time. They come in pairs. One particle, one antiparticle. They pop into existence and then almost instantly annihilate each other, like tiny sparks, flickering in and out of reality. Normally, this happens everywhere, all the time. You just don't notice it. But near a black hole, something strange occurs. At the edge of a black hole, what we call the event horizon gravity is so intense that it disrupts these particle pairs. Instead of annihilating each other, one particle falls into the black hole, the other escapes. And when that escaping particle leaves, it carries energy away from the black hole, very slowly, very quietly, but continuously. This process is called Hawking radiation, and it leads to a shocking conclusion. Black holes slowly evaporate. Not quickly, not dramatically, but over incredibly long periods of time. They lose mass, they shrink, and eventually they disappear. Let that sink in for a moment. The most powerful objects in the universe, the ones that seem completely unstoppable, are slowly leaking themselves out of existence. Now, here's where our curiosity loop tightens. We asked earlier, does anything truly last forever? Black holes were our best candidate, and now even they are temporary. But the story gets even stranger, because the larger a black hole is, the slower it evaporates. A small black hole might disappear relatively quickly, but the supermassive black holes at the centers of galaxies, they take absurd amounts of time. We're talking about timescales like 10 to the power of 100 years. That's a 1 followed by 100 zeros. A number so large, it barely has meaning. To put that into perspective, the current age of the universe is about 10 to the power of 10 years. So, black holes can last trillions of trillions of trillions of times longer than everything we've experienced so far. And during that time, they become the dominant objects in the universe. Everything else fades, decays, disappears, until only black holes remain. This era is sometimes called the black hole era, a universe filled with darkness, punctuated only by these silent, invisible giants. But even in this era, change is still happening. Black holes continue to evaporate, slowly releasing tiny amounts of radiation. At first, it's almost nothing, barely detectable. But as the black hole shrinks, something surprising happens. It starts to lose mass faster, which means the process accelerates. Faster and faster, until, in its final moments, the black hole releases a burst of energy and vanishes, a final whisper, a last flicker, then nothing. Now imagine this happening, not once, but everywhere. Across the universe, the last black holes begin to disappear, one by one, over unimaginable stretches of time, until finally, the very last black hole evaporates, and with it, the last major source of energy in the universe is gone. This is a turning point, a profound one, because after this moment, there are no more complex structures left, no stars, no planets, no black holes, only particles, scattered, isolated, drifting through an ever-expanding void. And now, we return to our second big question. What is the universe made of when everything decays? At this stage, the universe is mostly composed of extremely low-energy particles, photons, neutrinos, possibly some electrons and positrons. If proton decay is real, then even atoms are gone. No nuclei, no structure, just a thin soup of elementary particles spread out across distances so vast that interactions are almost non-existent. The universe becomes almost perfectly empty, but not completely, because something still remains, something subtle but incredibly important: energy. Even though it's spread out, even though it's incredibly weak, it's still there. And as long as energy exists, there is still the possibility of change. Which brings us to a new, deeper question. Can something meaningful still happen in a universe this empty? At first glance, it seems unlikely. With particles so far apart, interactions become almost impossible. But almost impossible is not the same as impossible. Given enough time, even the rarest events can occur. And here's where things take a strange turn, because in a universe governed by quantum mechanics, randomness is fundamental, which means even in near-total emptiness, fluctuations can still happen, tiny, spontaneous changes in energy, moments where something appears out of nothing. Most of these fluctuations are small, insignificant, gone almost instantly. But given enough time, something larger could occur. A particle, a structure, maybe even something more complex. And this leads to one of the most bizarre ideas in physics, the concept of a Boltzmann brain, a self-aware entity that randomly forms out of chaos, exists for a brief moment and then disappears. It sounds absurd, almost like science fiction. But mathematically, it's not impossible, and if the universe lasts long enough, it might even be inevitable. Which raises a deeply unsettling thought. In the far future, is it more likely for consciousness to arise randomly than for a structured universe like ours to exist? We won't answer that yet, but keep it in mind, because now we're approaching the final stages of our journey. The universe is almost completely empty, almost completely still, and yet time continues to pass, which brings us back to our first question. What does time mean when nothing changes? We've been circling this idea, getting closer with each step, and in the next part, we're going to confront it directly, because the answer might force us to rethink what time actually is, not as something fundamental, but as something that only exists when the universe has something to do. And if that's true, then in the final state of the cosmos, time itself may begin to dissolve. But if time disappears, what does that mean for existence, for reality, for anything at all? That's where we're headed next. And the answer is quieter and stranger than you might expect. At this point in the universe, something subtle begins to slip away. Not matter, not energy, but something we've been quietly relying on this entire time: time itself. We've followed the universe through its long decline. Stars burned out, galaxies drifted apart, black holes evaporated, and now we are left with a universe that is almost perfectly still. Here's the mini-hook. What if time doesn't actually exist without change? Think about how you experience time right now. You don't feel time directly. You feel change, a heartbeat, a breath, the movement of light across a room. Time, in a very real sense, is just a way of measuring change. But in this future universe, what is left to change? Particles are so far apart, they rarely interact. Energy is so evenly spread, nothing flows. There are no clocks, no cycles, no events you could point to and say, that happened after that. So here's the unsettling idea. If nothing changes, does time still pass? Physics gives us a strange answer. In many equations, time is just a parameter, a variable. It ticks forward, whether anything happens or not. But from a physical, meaningful perspective, time might be something else entirely, something that only exists when there are differences in the universe. This idea is deeply connected to something called entropy. Entropy is often described as disorder, but a better way to think about it is this. Entropy measures how many ways a system can be arranged without changing its overall appearance. Low entropy, a tidy room, everything in its place. High entropy, a messy room, everything scattered. The universe naturally moves from low entropy to high entropy, from order to disorder, and that process creates the direction of time. This is what we call the arrow of time. You remember the past, not the future, because the past was more ordered. The future, more disordered. But in the far future of the universe, entropy reaches its maximum. Everything is as spread out, as uniform as it can possibly be. No gradients, no differences, no direction. And without a direction, what happens to the arrow of time? It disappears. Here's a way to visualize it. Imagine watching a movie. At first, there's motion, a clear sequence of events, beginning, middle, end. Now imagine the movie freezes, one single frame, nothing changes, no movement. In that frozen frame, can you still talk about before and after? Not really, because those concepts depend on change. And that's what the universe is becoming, a frozen frame. But here's where things get even more interesting, because earlier we said something important. Even in this nearly empty universe, quantum fluctuations can still happen. Tiny, random events, small disturbances in the stillness. So the universe is not perfectly frozen, just almost. And that almost changes everything. Because as long as even the smallest fluctuations exist, there is still a kind of time, a faint echo of it. Which leads us to a deeper, more philosophical question. Is time fundamental, or is it an illusion created by change? Some physicists believe time is not a basic ingredient of the universe, not like space, not like energy. Instead, it might emerge from relationships between things, from interactions, from change itself. No change, no time. And if that's true, then in the final state of the universe, time doesn't end dramatically. It simply fades away. Now pause for a moment, because this connects to all three of our original questions. What is the fate of matter? It dissolves. Can anything survive without energy? Barely, and only for a while. And what happens to time? It becomes meaningless. But we're not finished. Because there's still one more layer to uncover. Here's the next mini-hook. What if this isn't the end at all? It might feel like we've reached the final chapter, a universe that is empty, still, timeless. But physics has a way of surprising us, because even in maximum entropy, even in near-perfect stillness, there is a possibility, however small, that something new could happen. Let's go back to those quantum fluctuations. In our current universe, they're tiny, insignificant, but over infinite time, even the most unlikely events become possible. Imagine shaking a box of puzzle pieces. If you shake it long enough, eventually they might fall into a complete picture. It's incredibly unlikely, but not impossible. Now apply that idea to the entire universe. In a sea of particles, random fluctuations could, in theory, create structure again. A particle cluster, a system, maybe even something resembling a star. And this leads to a wild, almost unbelievable idea. The universe might restart itself through randomness, not in a dramatic rebirth, not a new Big Bang, but small, local pockets of order emerging out of chaos. And if that's possible, then the story of the universe never truly ends. It just becomes infinitely quiet, with rare, fleeting moments of something happening. Now, here's the deeper twist. If time depends on change, and change only happens during these rare fluctuations, then time itself becomes fragmented, long stretches of nothing, punctuated by brief moments of existence, almost like the universe is blinking. Existence, pause, existence, pause, and in between those moments, there is no meaningful time at all. Which brings us to a haunting thought. If you existed in that future, would you even experience continuity? Or would reality feel like isolated flashes with nothing connecting them? We don't have a clear answer, not yet, but we're getting closer. Because in the next part, we're going to explore one of the strangest possibilities of all. What if the universe doesn't just fade away or randomly fluctuate? What if it cycles? What if endings are actually beginnings in disguise? And what if the death of the last star is not the end of the story, but the setup for something entirely new? That's where we're heading next, and the answer might change how you think about existence itself. What if this isn't the end? What if everything we've just described, the fading stars, the evaporating black holes, the slow collapse into silence, is not a final chapter, but a transition? Here's the mini hook. What if the universe doesn't die, but resets? It sounds almost too hopeful. After everything we've seen, the endless expansion, the loss of energy, the breakdown of matter, a reset feels impossible. But physics doesn't always follow intuition, and some of the most serious theories about the universe suggest something surprising. The end might look very similar to the beginning. Let's go back to something we touched on earlier, entropy. Entropy always increases. That's one of the most fundamental rules in physics. The universe moves from order to disorder, from structure to randomness. But here's the strange part. The very early universe right after the Big Bang was actually a state of very low entropy. Highly ordered, highly uniform, which creates a paradox. If entropy always increases, why did the universe start in such an ordered state? We don't fully know. But this question opens the door to something deeper, because if the universe began in low entropy and ends in maximum entropy, then those two states, the beginning and the end, might not be as different as they seem. Both are incredibly simple. Both are extremely uniform. Both lack complex structure. And that leads to a radical idea. What if the end of the universe becomes the beginning of another? Not in a dramatic explosion, not necessarily a new Big Bang in the way we imagine it, but through a transformation. Some physicists propose a concept known as a cyclic universe. In one version of this idea, the universe expands, slows, and then eventually contracts, collapsing back into a dense state before expanding again. A cosmic heartbeat, expansion, contraction, repeat. But our current observations suggest something different. The universe isn't slowing down, it's accelerating. So a simple bounce doesn't seem likely. Which brings us to a more subtle and more fascinating theory. Imagine the universe at its very end. Maximum entropy. No structure. No meaningful time. Now imagine zooming out even further. In that state, there are no clocks, no scales, no way to measure size or duration. And here's the strange consequence. If there's nothing to measure, then concepts like big and small, long and short lose their meaning, which means the universe at its end could be mathematically indistinguishable from the universe at its beginning. This idea is at the heart of a theory called conformal cyclic cosmology. It suggests that the universe doesn't restart in a violent way. Instead, the far future of one universe becomes the Big Bang of the next, not through destruction, but through transformation. Imagine taking an image, and stretching it infinitely. Eventually, all details disappear, everything becomes smooth, uniform. Now imagine compressing that same image down to a single point. The result looks the same. In both cases, there are no distinguishable features, no structure, and that's the key insight. At the extremes, infinitely large or infinitely small, the universe may look identical, which means the end and the beginning could be the same state. Now pause for a moment, because this reframes everything. The death of the last star is no longer just an ending. It's part of a cycle, a transition. And here's where our curiosity loops begin to connect. We asked, what is the fate of matter? It dissolves into simplicity. Can anything survive? Not in its current form. What happens to time? It fades and loses meaning. And now we're asking something even bigger. Does the universe itself continue? In this model, the answer is yes, but not in a way we would recognize. There is no memory carried over, no information preserved in a familiar sense. The next universe doesn't remember this one, and yet it emerges from it, which raises a deeply philosophical question. If something continues without memory, is it truly the same thing? Think about yourself for a moment. Every cell in your body is replaced over time. Your thoughts change, your memories evolve, and yet you still feel like the same person. Now imagine removing memory entirely. Would there still be a sense of continuity? Or would each moment feel like a completely new existence? That's the kind of question we're dealing with here, because in a cyclic universe, existence continues, but identity may not. And here's the next mini hook. What if this has already happened before? What if our universe is not the first? What if it's one cycle in an endless chain? A sequence of universes, each emerging from the quiet death of the last. If that's true, then the night sky you see today is not just filled with stars, it's the result of countless previous endings, each one giving rise to something new. And yet, we have no direct evidence of this. It remains a hypothesis, a possibility, but it's one that fits, surprisingly well, with what we know. Now here's where things become even more intriguing, because if the universe can cycle, then the idea of a final end may not exist at all. Instead, there is only transformation, endings that become beginnings, silence that becomes creation. And that changes how we think about everything, because the death of the last star is no longer something to fear. It's part of a much larger story, a story that might never truly end, But we're not done yet. Because there's still one possibility we haven't explored, a possibility that challenges even this idea of cycles. What if the universe doesn't repeat and doesn't restart? What if it does something completely unexpected? In the next part, we're going to explore the strangest outcome of all, a universe that doesn't just fade or loop, but transforms into something we can barely describe. And hidden inside that possibility might be the most profound answer yet to what happens after everything ends. What if everything we've imagined so far is still too simple? What if the universe doesn't just fade into silence, doesn't reset, doesn't cycle, but transforms into something so unfamiliar we wouldn't even recognize it as a universe anymore? Here's the mini-hook. What if the end of the universe isn't empty, but unknowable? Up to now, we've followed a fairly intuitive path. Stars die, matter decays, energy spreads out, time fades. It's a story of loss, a slow unraveling. But physics, especially at its deepest levels, doesn't always move towards simplicity. Sometimes it moves towards something stranger. To understand this, we need to revisit a quiet assumption we've been making the entire time. We've been treating the universe like a stage, a place where things happen, particles move, energy flows, time passes. But what if the stage itself changes? Not just what's inside the universe, but the rules that define it. Because at extreme scales, both incredibly large and incredibly small, the laws of physics begin to blur. And this leads to one of the most profound ideas in modern science. The laws of physics might not be fixed. They might evolve, shift, or even emerge from something deeper. Now, here's where things get interesting. At the very end of the universe, we reach conditions unlike anything we've ever observed. No structure, no interactions, almost no energy gradients, a kind of ground state of reality. And in this state, some physicists suggest the universe might undergo a transition. Not a collapse, not an explosion, but a transformation in its fundamental nature. Think of water. At different temperatures, it behaves completely differently. Solid ice, liquid water, invisible vapor, same substance, different phases. Now imagine something similar, but for the universe itself, a phase change of reality, where space, time, and matter are no longer the concepts we understand. This idea appears in several areas of theoretical physics. For example, in quantum gravity, space and time may not be fundamental at all. They could be emergent, meaning they arise from deeper, more basic structures, like how a wave emerges from the motion of water molecules. You don't see the individual molecules, you see the pattern. Now apply that to reality. What if space is just a pattern? Time, just a pattern? And at the end of the universe, that pattern dissolves, not into nothing, but into something more fundamental, something we don't yet fully understand. Now pause, because this changes the question entirely. Instead of asking what remains at the end, we start asking, what is reality made of? Beneath space and time, and here's the unsettling truth, we don't know, but we have hints. Some theories suggest that at the deepest level, the universe is made of information, not matter, not energy. Information, bits of structure, relationships, connections. In this view, particles are just patterns of information. Space is a network. Time is a sequence of changes in that network. So what happens when the universe reaches maximum entropy? When all patterns are smoothed out, all differences erased, Does the information disappear? Or does it reorganize and into something else? This leads us to one of the strangest possibilities of all. The universe doesn't end as emptiness. It becomes a kind of information soup, a state where everything that ever existed is still there, but completely scrambled, like a book where all the letters still exist, but are randomly rearranged. The story is gone, but the information remains. Now, here's the twist. If information is never truly destroyed, then, in principle, it could be rearranged again. Not necessarily into the same structure, not necessarily into anything recognizable, but into something. And that opens the door to a radical idea. The universe might transform into entirely new kinds of reality. Not stars, not galaxies, but structures we can't yet imagine, because our imagination is built on the physics we know, and this new state might follow different rules entirely. Now, here's the next mini-hook. What if consciousness itself is part of that transformation? Earlier, we talked about Boltzmann brains, random fluctuations creating brief moments of awareness. But what if consciousness is more deeply connected to information? Not just a byproduct of brains, but a pattern that can exist in different forms, in a universe where information persists, even in a scrambled state. Could awareness re-emerge? Not as humans, not as anything biological, but as patterns, self-organizing, out of the noise. It's speculative, but not impossible, and it leads to a haunting idea. Even at the end of everything, something might still be aware. Not continuously, not in a stable way, but in fleeting, fragmented moments. And if that's true, then the universe never becomes completely silent. It becomes whispers, brief flashes of structure, of awareness, of existence. Now, let's step back. We've explored several possible endings, a slow fade into heat death, a cycle of rebirth, a transformation into something new. Each one answers our original questions differently. What happens to matter? It dissolves or transforms. Can anything survive? Maybe, in unexpected forms. What happens to time? It fades or becomes irrelevant. But there's one final question that ties everything together. Here's the deeper mini-hook. Why does anything exist at all instead of nothing? Because even in all these scenarios, something remains. Energy, information, possibility. The universe never becomes pure nothing, and that might be the most profound mystery of all. Why is there something rather than nothing? We don't have the answer, but by following the universe to its end, we get closer to the question itself. And sometimes, that's the most important step. In the next part, we're going to bring everything together, not just the physics, but what it means. Because the fate of the universe isn't just a scientific story, it's a story about existence, about time, about us, and hidden inside it might be a perspective that changes how you see everything. Not just the end of the universe, but this moment, right now. What does all of this actually mean for us? Not in the distant future, not in trillions of years, but right now. Here's the mini-hook. What if the end of the universe is already shaping your life today? It sounds strange at first, after all. The death of the last star is so far away that it feels completely disconnected from our lives, but the truth is, the same laws that will one day bring the universe to silence are already at work in this moment. Entropy is increasing, energy is flowing, time is moving forward, and everything you experience, every thought, Every memory, every moment is part of that process. Let's bring it closer. Right now, your body is a highly ordered system, cells organized, signals flowing, energy being used efficiently, but maintaining that order. Our requires constant energy, food, oxygen, heat exchange. Without it, your body would slowly move toward disorder, toward equilibrium, toward the same fate. As the universe now zoom out, a star is doing the same thing, burning fuel to maintain structure, holding itself together against collapse. And just like you, it can't do that forever. So here's the connection. You and the stars are following the same rules. Different scales, different timelines, same physics, which leads to a quiet realization. The story of the universe is not separate from you. You are part of it, not metaphorically, literally. The atoms in your body were forged inside stars, carbon, oxygen, iron, all created in stellar cores billions of years ago, which means you are made of the remnants of ancient stars. And one day, those atoms will continue their journey, rearranged, reused, return to the universe, just like everything else. Now, here's where the perspective shifts. We often think of endings as something negative. The end of a life, the end of a star, the end of the universe. But from a physical perspective, endings are also transformations. Nothing truly disappears. It changes form, energy spreads out, matter rearranges, information evolves. And this brings us to a deeper insight. The universe is not a story about things lasting forever. It's a story about things changing, constantly, inevitably, beautifully. Now here's the next mini-hook. If everything eventually fades, does anything actually matter? It's a question that comes up often, and it can feel unsettling. If the universe ends in darkness, if all structures dissolve, if even time loses meaning, what's the point? But physics offers an unexpected answer. Meaning doesn't come from permanence, it comes from process. Think about a piece of music. It exists in time. It begins and ends. If you tried to make it last forever, it wouldn't be music anymore. It's the progression, the movement from one note to another, that gives it meaning. Now apply that idea to the universe. The value is not in it lasting forever. It's in the unfolding, the formation of stars, the emergence of life, the experience of consciousness, moments, brief but real. And that includes this moment, right now. You are experiencing something incredibly rare, a universe with structure, with energy gradients, with complexity. A universe where stars still shine, where thoughts can happen, where questions can be asked. And that's not guaranteed. In fact, it's temporary, which makes it extraordinary. Now let's return to our three big questions. What is the fate of matter? It changes, dissolves, transforms, but along the way it creates structure, life, experience. Can anything survive? Not in a permanent sense, but patterns can re-emerge. Moments can repeat in new forms. And what happens to time? It flows, then fades. But while it exists, it allows everything else to happen. Now, here's the deeper mini-hook. What if the most important part of the universe is not its beginning or its end, but the middle? The part where things happen, where stars shine, where life emerges, where awareness exists. Because that's where we are. Not at the beginning, not at the end, but in the brief window where the universe is alive. And that changes how we see everything. Because instead of focusing on the inevitable end, we can recognize the rarity of the present, a universe capable of understanding itself through you. Now pause, because this might be the most surprising idea of all. The universe has spent billions of years evolving structure, complexity, order, and in doing so, it has created something unique, a way to observe itself, you, your thoughts, your awareness, are part of the universe, looking back at itself, trying to understand its own nature, its own beginning, its own end. And that's something that may not exist in the far future, when everything fades, when structure disappears, when time loses meaning. There may be no one to ask these questions, which means this moment is special, not because it lasts forever, but because it doesn't, and that gives it weight, meaning, presence. So when we ask, what happens after the last star dies? We're not just asking about the future, we're asking about the nature of existence itself and our place within it. In the next part, we're going to go even deeper, because there's one final layer to explore, not just what happens to the universe, but what happens to reality when observation itself disappears. When there are no more observers, no more questions, no more awareness, what does the universe become when no one is left to experience it? And does that question even have meaning? That's where we're heading next. What happens when there are no observers left? No eyes to see, no minds to think, no awareness to ask questions. Here's the mini-hook. If no one is there to experience the universe, does it still exist in the same way? It's a strange question. At first, it sounds philosophical, almost abstract, but it's actually rooted in real physics. Because when we look closely at how the universe behaves, especially at the quantum level, the role of observation becomes surprisingly important. Let's start with something simple. In everyday life, objects seem to have definite properties. A rock is here, a star is there, a particle has a position. But in quantum physics, things are not so clear. Particles don't have definite positions until they are measured. Instead, they exist in a range of possibilities, not here or there, but a kind of blur of potential states. This is called a superposition. Now here's where it gets strange. When a measurement happens, the system chooses a definite state. The blur becomes a point. This is often described as the collapse of the wave function. And it raises a deep question. What counts as a measurement? Does it require a conscious observer, a human mind? Or can any interaction, any exchange of information count as observation? Most physicists lean toward the second idea. A measurement doesn't need a person. It just needs interaction. When a particle bumps into another particle, that's enough. So even in a universe without life, interactions can still define reality. But now, think about the far future. Particles are incredibly far apart. Interactions are extremely rare. Almost nothing measures anything else, which means quantum systems can remain in superposition for incredibly long times. The universe becomes less definite, more probabilistic, more like a cloud of possibility than a fixed, solid structure. Now pause, because this leads to a fascinating idea. In the absence of observers, the universe might not settle into a single, clear state. Instead, it exists as a vast spread of possibilities, not one history, but many potential histories. Now here's the deeper mini-hook. What if reality itself becomes fuzzy when no one is there to observe it? Imagine a book where the words constantly rearrange themselves. As long as someone is reading, the story stays fixed. But the moment no one is watching, the letters begin to shift. the narrative dissolves. That's one way to think about this future universe, not a stable story, but a fluid set of possibilities. Now, this doesn't mean reality disappears. It means reality becomes less defined, less constrained. And that brings us to a profound question. Is the universe inherently definite, or does it require interaction to become real? We don't have a final answer. But experiments suggest that interaction plays a key role in shaping what we observe as reality. And in a universe where interactions are nearly gone, reality itself may become something very different. Now let's connect this back to our earlier ideas. We talked about time fading, entropy reaching its maximum, structure dissolving. Now we're adding another layer. The clarity of reality itself may begin to dissolve, not into nothing, but into possibility. Now here's where things get even more intriguing, because even in this nearly observerless universe, there is still one kind of observer left: the universe itself. Every interaction, no matter how small, creates information. And that information acts like a record, a trace of what happened. So, in a sense, the universe is constantly observing itself, even without consciousness. But as interactions fade, even these records become rare. And without records, the distinction between past and future becomes blurred. Which brings us back to time. If time depends on change, and change depends on interactions, and interactions are disappearing, then the very fabric of cause and effect begins to weaken. Events are no longer clearly linked. The universe becomes less like a chain of events and more like a collection of disconnected possibilities. Now, here's a thought. That might feel unsettling. If there are no observers and no clear sequence of events, does the concept of happening still apply? Or does the universe simply exist without unfolding? We're approaching the edge of what we can even describe, because our language, our intuition, is built on a world where things happen in sequence. But this future universe may not follow that pattern. It may be something else entirely. Now, let's return to one of our original questions. Can anything survive? In a universe like this, survival doesn't mean what it used to. There are no stable structures, no continuous processes. But there are still possibilities. And occasionally those possibilities might align into something recognizable. A fluctuation, a brief structure, a moment of order. And in that moment, something like an observer could emerge. Not permanently, not continuously, but briefly, a flash of awareness, and then gone again. Now imagine this happening over and over, across infinite time. Tiny sparks of observation in a vast sea of possibility. The universe momentarily becoming aware of itself, then fading back into silence. And this leads to a haunting idea. Even at the end of everything, the universe might still occasionally experience itself. Not as a continuous story, but as isolated moments. Now let's step back. We've explored the fate of matter, the fate of energy, the fate of time. And now, the fate of observation, each one fading, transforming, becoming less defined, but not disappearing completely. Instead, they become rare, fragmented, subtle. And this brings us to one final mini-hook for this part. What if existence itself never fully ends, but becomes infinitely diluted, not gone, just spread so thin that it's almost impossible to detect, like a whisper in an endless void? In the next part, We're going to take everything we've learned and confront the biggest question of all. Not just what happens to the universe, but what it all means. Is there a final answer? A true ending? Or is the universe an endless process with no ultimate conclusion? And if there is no final answer, what does that say about the nature of reality itself? That's where we're going next, and it might be the most unsettling and most beautiful idea yet. Is there a final answer, a true ending to all of this? Or have we been asking the wrong question the entire time? Here's the mini hook. What if the universe doesn't have an ending because it was never a story to begin with? We've been describing the universe as if it were a narrative, a beginning, a middle, an end, the Big Bang, the age of stars, the slow fade into darkness. It feels natural because that's how we experience life. But the universe might not work that way because a story implies direction, a clear sequence, a sense of progression towards something. And as we've seen, those ideas begin to break down. Time fades, causality weakens, events become rare and disconnected. So what if the universe isn't a story at all? What if it's something else? Something without a final chapter. Let's go back to one of our deepest questions. Why is there something rather than nothing? It's a question that has puzzled scientists and philosophers for centuries. And one possible answer is surprisingly simple. Maybe nothing is not a stable state. Think about it. What is nothing? No space, no time, no energy, no laws. But if there are no laws, then there's nothing preventing something from existing. In other words, nothing might be inherently unstable. And if that's true, then existence doesn't need a cause. It doesn't need a beginning. It just is. Now pause, because this idea flips everything. Instead of asking, when did the universe begin? We ask, was there ever a true beginning at all? And if there wasn't, then the idea of an end becomes less clear, because endings only make sense if there was a beginning. Now, here's the deeper mini hook. What if the universe is not moving toward an end, but simply changing form endlessly? Not in a neat cycle, not in a predictable loop, but in a continuous transformation like a river. The water flows, the shape changes, the patterns shift, but the river itself doesn't have a final destination. It just continues. Now, let's connect this back to everything we've explored. Matter doesn't disappear. It transforms. Energy doesn't vanish. It spreads. Time doesn't end abruptly. It fades. Observation doesn't stop completely. It becomes rare. At every level, we see the same pattern, not absolute endings, but transitions, which suggests something profound. The universe may not be designed to finish. It may be designed to evolve endlessly. Now here's where things get even more interesting, because if there is no final end, then the question shifts again. Instead of asking, what happens after the last star dies, we ask, what kinds of existence are possible beyond what we understand? Because the universe might not stop. It might simply move into regimes that are unfamiliar, new forms of structure, new kinds of interactions, new definitions of reality, things that don't look like stars or galaxies or even particles, but still exist. Now, let's return to one of our earlier ideas, information. If information is never truly destroyed, then everything that has ever happened is in some sense still part of the universe, not in a way we can easily access, not in a way that preserves identity, but as patterns, as possibilities. And if those patterns can be rearranged, then the universe is not just evolving forward, it's exploring a vast space of possibilities, every configuration, every structure, every arrangement. Over enough time, everything that can happen might happen. Now, here's a thought that feels almost overwhelming. What if the universe is not a single path, but an infinite exploration of all possible paths? Not one history, but many. Not one ending, but countless transformations. And we are experiencing just one slice of that. Now bring it back to the present. Right now, you are part of a very specific configuration of the universe. A rare one, a structured one, a conscious one. And it won't last forever. But that doesn't make it meaningless. It makes it unique. Because in an infinite sea of possibilities, this exact moment is unlikely, precious. Now here's the next mini hook. If everything is possible, why does the universe look the way it does right now? Why stars? Why galaxies? Why life? Why not something completely different? This is one of the biggest open questions in physics. Some scientists suggest that the universe we observe is just one of many possible configurations, a selection from a larger landscape. And we happen to exist in one that allows structure, complexity, observation. But there could be others, universes with different laws, different constants, different outcomes. And if that's true, then our universe is not the only story. It's one of many. Now, let's step back one more time. We started with a simple question. What happens after the last star dies? And we followed it. Through darkness, through decay, through the fading of time, through the limits of observation, all the way to the edge of understanding. And what we found is not a clear ending, but something more subtle, a shift in perspective. The universe doesn't end in a single moment. It becomes less structured, less active, less defined, but never completely gone, always changing, always evolving. Which brings us to one final idea for this part. Maybe the universe is not something that exists, but something that is constantly happening, not a static object, but a process. And processes don't have endings in the same way objects do. They transform, they continue, they shift into new forms. And that might be the most accurate way to think about reality. Not as a thing with a beginning and an end, but as an ongoing event. In the next part, we're going to take this idea even further, because there's one last question left. Not about the universe, but about us. If everything is part of this endless process, then what role do we play in it? Are we just temporary observers, or are we part of something deeper, something that continues even beyond the death of the last star? That's where we're going next, and the answer might be closer than you think. What role do we play in all of this, in a universe that stretches across unimaginable time, that builds stars, destroys them, and slowly fades into silence? Where do we fit? Here's the mini hook. What if you are not just in the universe, but part of how the universe understands itself? It sounds poetic, almost philosophical, but there's something deeply real behind it. Because everything we've described so far, entropy, time, matter, energy, follows physical laws, and those same laws have led, at least once, to something extraordinary. Consciousness, the ability for the universe and to become aware. Now think about that. For billions of years, the universe existed without awareness. Stars formed, galaxies collided, black holes grew, but there was no one to notice, no one to ask questions, no one to wonder what it all meant. And then something changed. on at least one small planet around one ordinary star. Matter arranged itself in a very particular way. Complex chemistry, self-replicating systems, eventually minds. And suddenly, the universe had a way to observe itself, not from the outside, but from within. Now, here's the deeper mini-hook. Is consciousness just an accident, or is it an inevitable outcome of the universe? We don't know for sure. But consider this. The same physical laws apply everywhere. The same atoms, the same forces, the same rules of chemistry. Which means, if the conditions are right, the process that led to life here could happen elsewhere, maybe many times. And if that's true, then consciousness is not unique. It's a pattern that emerges when matter reaches a certain level of complexity. Now connect that to the future of the universe. We said that structure fades, energy spreads out, interactions become rare, which suggests that consciousness, as we know it, cannot survive indefinitely. There won't be stable environments, no steady energy sources, no long-lasting systems. But here's where things get interesting. We also said that fluctuations can still happen, rare, unpredictable, but possible. And in those fluctuations, structure can briefly reappear, which means, in principle, consciousness could reappear too, not continuously, not as civilizations, but as fleeting moments. Now pause, because this leads to a strange possibility. The universe might not just create awareness once and then lose it forever. It might create awareness again and again in scattered moments across time, tiny flashes of understanding in an otherwise silent cosmos. Now, here's the next mini-hook. What if awareness is one of the rarest and most important things the universe can produce? Think about everything else. Stars burn, galaxies form, black holes grow. All of it follows predictable patterns. But awareness? That's different. It doesn't just exist. It experiences. It reflects. It asks questions like, what is this? Why does it exist? What happens next? And those questions are not trivial. They are part of the universe exploring itself. Now, let's go deeper. When you look at the night sky, you're not just seeing stars. You're seeing light that has traveled across billions of years, information encoded in photons, and your mind is decoding that information, turning it into understanding, which means you are part of a process where the universe takes in information and makes sense of it. Now imagine the far future. No stars, no light, no observers. That process stops. The universe continues, but it is no longer being understood. No one is asking questions. No one is interpreting reality. And that changes something fundamental, because without observers, there is no perspective, no meaning assigned to events. Things happen, but nothing interprets them. Now, here's the deeper question. Does meaning exist without someone to perceive it? From a purely physical standpoint, probably not. Meaning is not a property of particles. It's something that emerges in minds, which means, in the far future, meaning itself may disappear. Not because the universe ends, but because there's no one left to assign meaning to it. Now let that sink in. The universe doesn't just lose structure, it loses interpretation. It becomes a system without narrative, without story, without understanding. And that brings us back to the present. Right now, meaning exists because you exist, because you can ask questions, because you can reflect, which means you are part of something incredibly rare, not just life, but awareness. Now, here's the next mini-hook. If awareness is temporary, does that make it less important? or more. It might seem like less. After all, it doesn't last forever. But think about it this way: a sunset doesn't last forever, a piece of music ends, a moment passes, and yet those things can be deeply meaningful, not despite their impermanence, but because of it. Now apply that to consciousness. The fact that awareness is temporary might be exactly what gives it value, because it creates a window, a brief period, where the universe can experience itself, where questions can be asked, where understanding can grow. And that window is where we are right now. Now let's connect this back to our larger story. We followed the universe from bright beginnings to dark endings, from structure to simplicity, from activity to stillness. And along the way, we discovered something unexpected. The universe doesn't just produce stars. It produces observers, and those observers change the story, because they introduce perspective, meaning, understanding. Which leads to one final thought for this part. Maybe the universe is not just a physical process, but a process that occasionally becomes aware of itself. And if that's true, then what we're doing right now, thinking, questioning, exploring, is not separate from the universe. It is the universe in one of its rare moments of self-awareness. In the next part, we're going to take this idea even further, because there's one last question we haven't fully faced. If awareness is part of the universe and the universe continues to change, what happens to awareness in the very end? Does it disappear completely, or does it transform into something we can't yet imagine? That's where we're going next. And the answer might be the most surprising one yet. What happens to awareness at the very end? Not just life, not just matter, but awareness itself. Here's the mini hook. Does consciousness disappear with the universe, or is it more resilient than we think? Up to now, we've assumed something that feels obvious. Consciousness depends on structure, brains, neurons, energy flow. Without those, there is no awareness, and in the far future of the universe, those structures disappear. Stars die, energy fades, matter dissolves. So it seems inevitable awareness must end too, but here's where things become less certain. Because we don't fully understand what consciousness is. Is it just a byproduct of complex biology? Or is it something more general, a pattern that can exist under the right conditions? We don't have a final answer. But we can explore possibilities. Let's start with what we know. Your brain is a physical system. Neurons fire, signals propagate, information is processed. And from that, subjective experience emerges. Now, here's the key idea. Consciousness seems to arise from information processing, not from any specific material, not from carbon itself, but from the pattern, the structure, the flow of information, which means, in principle, other systems could produce awareness too, not just biological ones. Now imagine the far future. Again, the universe is cold, sparse, almost empty. No stable planets, no stars, no long-term energy sources. At first glance, there's no place for consciousness. But remember what we discussed earlier. Quantum fluctuations, random events, tiny pockets where structure briefly appears. Now combine these ideas. If consciousness is a pattern, and patterns can briefly form, then awareness might still occur. Not continuously, not as a stable identity, but as flashes, a moment of awareness, emerging from randomness and then disappearing. Now pause. Because this is one of the strangest possibilities we've encountered, a universe that occasionally becomes aware for just an instant. then returns to silence. Now, here's the deeper mini-hook. What would it feel like to exist for just a moment, with no past and no future? Imagine becoming aware with no memory, no history, no sense of time, just a single instant of experience, and then nothing. Would that moment feel meaningful? Would it feel like anything at all? We don't know, but it challenges how we think about existence, because we usually define ourselves through continuity, memories, identity, a sense of ongoing self. But in this future universe, those things may not exist, only isolated moments. Now, let's go even deeper. Some theories suggest that consciousness might not require a physical brain in the way we think. Instead, it could arise from any system that processes information in the right way, even abstract systems, even the universe itself. Now here's a bold idea. What if the universe as a whole has its own form of awareness, not like a human mind, not with thoughts or emotions, but as a system that processes information across vast scales? This idea is speculative, but it appears in some interpretations of physics and philosophy, and it leads to a fascinating possibility. Even as individual observers disappear, the universe might still process information, still evolve patterns, still undergo transitions, and in doing so, it might retain a kind of implicit awareness, not localized, not personal, but distributed. Now connect this back to entropy. As entropy increases, structure decreases, which suggests that this kind of awareness would also fade, becoming weaker, more diffuse, until eventually it becomes almost indistinguishable from randomness, but not completely gone. Now, here's the next mini-hook. What if awareness doesn't end, but dissolves into the fabric of the universe, not as individuals, not as minds, but as potential, as the capacity for experience embedded in the structure of reality? Now let's bring it back to our original journey. We started with the death of the last star. We followed matter as it decayed, energy as it spread out, time as it faded, observation as it became rare, and now awareness as it transforms. At every step, we expected endings, but what we found instead were transitions. Now let's revisit our three core questions one more time. What is the fate of matter? It dissolves into simpler forms. Can anything survive? Not in a stable, permanent way, but patterns can re-emerge. And what happens to time? It loses meaning as change disappears. Now we add a fourth question. What happens to awareness? And the answer seems to be it fades, transforms, becomes rare, but may never completely vanish. Now here's the deeper insight. The universe doesn't just produce structure, it produces the conditions for experience, and those conditions can appear, disappear, and reappear. Which means awareness is not a permanent feature of the universe, but it's also not a one-time event. It's something that can emerge whenever the right conditions exist. Now pause, because this leads to a powerful realization. The awareness you are experiencing right now is part of a rare window, a brief alignment of conditions that allows the universe to experience itself, and that window will not last forever. But that doesn't make it insignificant, it makes it extraordinary. Now here's the final mini-hook for this part. What if the universe is not trying to preserve awareness, but to create it? Again and again, in different forms, not continuously but in bursts, moments of clarity, in an otherwise silent cosmos. And if that's true, then awareness is not an exception, it's part of the process, a recurring feature of a universe that is always changing. In the next part, we're going to bring everything together, not just the physics, not just the philosophy, but the full picture. Because there's one final perspective left to explore, a way of looking at the universe that doesn't focus on beginnings or endings, but on something deeper, something that might redefine what it means for anything to exist at all. And once you see it, you may never look at the universe the same way again. What if we've been looking at this the wrong way the entire time? Not just slightly wrong, but fundamentally backwards. Here's the mini hook. What if the universe is not something that exists in time, but something where time exists inside it? It sounds subtle, but it changes everything. Up to now, we've been treating time like a river, flowing forward, carrying the universe from beginning to middle to end. The Big Bang, the age of stars, the final darkness. But what if that's just how it feels from the inside? What if time is not the container, but something contained? Let's explore this. In modern physics, especially in theories that try to unify gravity and quantum mechanics, there's a surprising idea. Time might not be fundamental. It might not exist at the deepest level of reality. Instead, it could emerge from relationships between things, changes, correlations, interactions. In other words, time might be something that appears when the universe has structure and disappears when it doesn't. Now think about the far future again. No stars, no structure, no meaningful change. We said earlier that time becomes meaningless, but now we can say something stronger. Time might not just lose meaning, and it might stop existing altogether, not because it ends, but because the conditions that create it are gone. Now pause, because this flips our perspective. Instead of imagining the universe moving through time, we imagine time emerging inside the universe only when certain conditions are met. Now, here's the deeper mini hook. What if past, present, and future all exist, but we only experience one slice of them? There's a concept in physics called the block universe. In this view, time is not something that flows. Instead, all moments exist simultaneously, like pages in a book. The beginning is there, the middle is there, the end is there. We just experience them one page at a time. Now imagine the entire history of the universe, laid out all at once. The birth of stars, the rise of life, the fading into darkness, all of it existing together. From this perspective, the universe doesn't move toward an end, it simply is, and what we call time is just how we experience it. Now here's where things get really interesting. If all moments exist, then the death of the last star is not something that hasn't happened yet. It's already part of the structure, just like your childhood, just like this moment. They all exist in different parts of the same whole. Now let that sink in. The universe doesn't begin and then end. It exists as a complete entity, with a beginning-like region and an end-like region. And we are inside it, moving through it. Now, here's the next mini hook. If all moments exist, what does that mean for change? Because change implies movement before and after. But in the block universe, everything is already laid out. Nothing changes in the global sense. Instead, change is something we experience locally as we move through different parts of the structure, like reading a story. The story doesn't change, but your experience of it does. Now connect this back to the end of the universe, the dark, silent future. still exists, but so does the bright, active present and the early universe. All of them are equally real within the structure. Now here's the deeper question: why do we experience time as flowing if everything already exists? One possible answer lies in entropy. We move from low entropy to high entropy, from order to disorder, and that gives us a sense of direction, a sense of forward. But from a global perspective, there is no preferred direction, just different regions with different levels of entropy. Now, let's bring this back to awareness. If all moments exist, then every moment of awareness also exists. Your past thoughts, your present experience, your future moments, all part of the same structure, which means, in a very real sense, nothing is ever truly lost, not because it continues, but because it is already there. Now here's the next mini hook. What if the end of the universe doesn't erase anything, because nothing actually disappears? In this view, the death of stars, the fading of structure, doesn't remove the past. It just defines another region of the whole. Now pause, because this gives us a completely different perspective on endings. An ending is not a deletion, it's a boundary, a part of the structure where certain conditions exist. Now let's connect everything we've explored so far. We talked about heat death, a universe with no energy gradients, no structure, no time. In the block universe view, that state exists, but so does every other state, which means the universe is not heading toward heat death. Heat death is simply one part of the entire structure. Now, here's the deeper insight. The universe might not be a process unfolding, but a complete structure that we experience piece by piece. Now bring it back to you. Right now, you feel like you are moving through time, from past to present to future. But in this view, you are moving through a fixed structure, experiencing different moments, one after another. Now, here's the final mini hook for this part. If all moments exist, then this moment is not just passing. It is part of something permanent. Not permanent in the sense of lasting forever in time, but permanent as part of the structure of reality. This moment, it exists, just like every other, and it always will, as part of the whole. Now, take a breath, because this changes how we think about everything. The end of the universe is not a disappearance, it's a region. The beginning is not a creation event, it's a region, and we are moving through this vast structure, experiencing it one moment at a time. In the next part, we're going to take this idea even further, because there's one final layer left. If the universe is a complete structure, and we are part of it, what determines the path we experience? Why this sequence of moments instead of another? And does that mean everything is already fixed? Or is there still room for something like choice? That's where we're going next. And it may change how you think, not just about the universe, but about your own life. If all moments already exist, then what determines the path you experience? Why this moment, followed by this one, and not something else? Here's the mini hook. If the universe is a complete structure, are you actually making choices, or just discovering them? It's a question that feels personal, because it's no longer just about stars or galaxies. It's about you, your decisions, your actions, your sense of control. If everything is already part of the structure of the universe, then does that mean everything is fixed? That your future is already there, just like your past? At first glance, It might seem that way. This idea is often called determinism, the notion that every event is the result of previous conditions following the laws of physics. If you knew the exact state of the universe and all its laws, you could, in principle, predict everything that will happen, every star forming, every atom moving. Every thought in your mind now pause, because that can feel unsettling. If everything is determined, where does that leave free will? Are your choices real, or are they just part of the unfolding structure? Now here's where things get more interesting, because quantum physics introduces something unexpected. At the smallest scales, events are not perfectly predictable. They are probabilistic. Instead of one fixed outcome, there are multiple possibilities, and only when an interaction occurs does one outcome become actual. Now connect this to the block universe idea. If all moments exist, then perhaps all possible outcomes also exist. Not just one path, but many. This leads to a fascinating concept. The universe might not be a single timeline, but a branching structure of possibilities. Every choice, every quantum event creates multiple potential paths, and reality is one of those paths. Now, here's the deeper mini hook. What if you are not moving through a single future, but navigating a landscape of possibilities? Imagine standing at a crossroads. One path goes left, another goes right. From your perspective, you choose. But from a larger perspective, both paths exist, and different versions of you could experience each one. This idea appears in interpretations of quantum mechanics, like the many worlds interpretation. In this view, every possible outcome actually occurs in separate branches of reality. Now let's be careful. This is not something we can directly observe. It's a theoretical framework, but it raises a powerful possibility. Your experience is one path through a vast network of possibilities. Now bring this back to the end of the universe. In one path, the universe fades into heat death. In another, it cycles. In another, it transforms into something entirely new. All of these possibilities could exist within the larger structure, which means there may not be a single ending. There may be many. Now here's the key question. If multiple paths exist, what determines which one you experience? This is where things become deeply subtle. From the inside, it feels like choice. You decide, you act, you move forward. But from the outside, it might look like a path, already embedded in the structure. Now here's the important insight. Even if the path exists, your experience of choosing is still real, because that experience is part of the structure. Your thoughts, your decisions, your awareness, they are not separate from the universe. They are events within it. Now here's the next mini hook. What if free will is not about changing the future, but about how you experience the path you're on? Think about a story. The ending is already written, but as you read it, you still feel suspense, curiosity, emotion. Your experience is real, even if the structure is fixed. Now apply that to life. Your future might be part of the structure, but your experience of moving through it is still unfolding, still meaningful, still real. Now, let's go deeper, because there's another layer to this. Your brain is constantly processing information, evaluating possibilities, making decisions, and those processes are part of the physical universe, which means your sense of choice is itself a physical phenomenon, not an illusion, but a process. Now, here's the deeper mini hook. What if you are the process by which the universe explores its own possibilities, not separate from it, but an expression of it, a system that evaluates options and moves through them. Now think about what that means. Every decision you make is not just personal. It's part of the universe, exploring a path, a specific configuration or among countless others. Now connect this back to our earlier idea. The universe might be exploring all possible states, and you are part of that exploration, not observing from the outside, but participating from within. Now, let's bring it back to the end. The death of the last star is one region of the structure, but so is this moment, so is every moment, which means the story is not just about where it ends, it's about the path through it, the experience, the unfolding. Now, here's the final mini hook for this part. If all paths exist, then the question is not what will happen, but what is it like to experience this path? And that shifts everything, because it moves the focus from prediction to experience, from outcome to presence. Now pause, because this is where everything comes together. The fate of the universe, the nature of time, into the role of awareness, the question of choice. They all point to the same idea. Reality is not just something that happens. It's something that is experienced, and that experience is part of the universe itself. In the next part, we're going to take one final step, because there's still one question left. If the universe is this vast structure of possibilities and experiences, why does it exist at all? Why this structure instead of another? And is there any deeper reason behind it? That's where we're going next, and it might be the most difficult and most fascinating question of all. Why this universe out of all possible ways reality could exist? Why this one? Here's the mini hook. What if the universe doesn't have a reason? And yet, that's exactly why it exists. It's one of the deepest questions we can ask. Not just how the universe evolves, not just how it ends, but why it exists at all. Why these laws of physics? Why these constants? Why a universe capable of stars, galaxies, life, awareness? Because when you really think about it, there are countless ways reality could have been different. Gravity could be stronger or weaker. Atoms might not form. Stars might never ignite. The universe could be a chaotic mess with no structure at all. And yet, it isn't. It has just the right conditions for complexity to emerge. Now, here's the deeper mini hook. Is that a coincidence or something more? Some scientists propose an idea known as the anthropic principle. It sounds complicated, but the core idea is simple. We observe this kind of universe because only this kind of universe allows observers to exist. In other words, we're here because the universe allows us to be here. If it didn't, we wouldn't be asking the question. Now, that might feel unsatisfying. It doesn't explain why the universe has these properties. It just explains why we find ourselves in one that does. But it points to something important. The conditions of the universe and the existence of observers are deeply connected. Now let's take it further. Some theories suggest that there isn't just one universe, but many, a multiverse, each with different laws, different constants, different structures. In this view, all possible versions of reality exist, and we happen to be in one, where stars form, where chemistry works, where life is possible. Now pause, because this changes the question. Instead of asking, why this universe? And we ask, why do we find ourselves in this particular one? And the answer might be, because it's one of the few where we can. Now, here's the next mini hook. What if reality is not a single design, but a vast landscape of possibilities, and we're inside one of them? Imagine a giant cosmic lottery. Each ticket is a different universe. Most of them are empty, chaotic, unstructured, but a few have the right balance, the right laws, the right constants. And in those, something remarkable happens. Structure emerges, stars ignite, life begins, awareness appears. Now, here's where it gets even more interesting, because once awareness exists, it begins to ask questions. It begins to reflect. It tries to understand the universe that made it possible, which means the universe is not just a physical system. It's a system that produces the ability to question itself. Now, let's go deeper. Some physicists and philosophers have proposed an even more radical idea. What if the universe exists because it is observable? Not in a mystical sense, but in a logical one. If a universe cannot be observed, cannot produce any form of awareness, then it might as well not exist in any meaningful sense, because there is no perspective from which it is real. Now, this is a controversial idea, but it highlights something important. Observation and existence may be more connected than we usually think. Now, here's the deeper mini-hook. What if reality requires observers just as much as observers require reality? A kind of loop. The universe creates observers. Observers perceive the universe, and through that perception, reality gains meaning. Now bring this back to the end of the universe. We said that observers disappear, awareness fades, meaning dissolves. So what happens then? Does the universe still exist in the same way? Physically, yes, but experientially, there is nothing. No perspective, no interpretation, which suggests something profound. The experience of the universe is temporary, but the structure remains. Now let's connect everything we've explored. The universe begins in a state that allows structure. Structure leads to complexity. Complexity leads to life. Life leads to awareness. Awareness leads to questions, and those questions bring us here. Now, here's the key insight. The universe doesn't just exist. It produces the conditions needed to understand itself, even if only temporarily. Now, here's the next mini-hook. What if the purpose of the universe is not something external, but something that emerges from within it? Not a designed purpose, but a natural outcome. A process where matter organizes into systems that can reflect, and in doing so, create meaning. Now think about that. Meaning is not built into atoms. It doesn't exist in particles. It emerges when awareness appears, which means meaning is something the universe creates through observers. Now bring it back to you. Right now, you are part of that process. You are a system through which the universe is being understood. Your thoughts, your questions, your curiosity are not separate from reality. They are part of it. Now, here's the final mini-hook for this part. If the universe creates awareness, and awareness creates meaning, then meaning is not something you find, it's something you participate in, not given, not fixed, but emerging in the interaction between you and reality. Now pause, because this ties everything together. The fate of the universe, the nature of time, the role of awareness, the question of existence. They all lead to the same place, a universe that is not just physical, but experiential, not just existing, but occasionally understanding itself, and that understanding is happening right now. In the next part, we're going to take the final step, because there's one last question left. Not about physics, not about cosmology, but about perspective. If everything we've explored is true, how should we see the universe? As something ending, or as something far more open, far more mysterious, and far more alive than we ever imagined? That's where we're going next, and it might be the most important shift of all. So, how should we see the universe after everything we've explored? The birth of stars, the fading of light, the slow unraveling of matter, the disappearance of time, the transformation of awareness. What kind of story is this, really? Here's the mini-hook. What if the universe is not a tragedy, but a process so vast that ending is the wrong way to think about it? It's easy to look at the future we've described and feel a sense of loss. A universe that grows dark, cold, silent, no stars, no life, no observers. It feels like an ending. But that feeling comes from how we think. We are used to stories, beginnings, climaxes, endings, and we project that structure onto the universe. But the universe might not follow that pattern, because what we've seen again and again is not destruction, it's transformation. Stars don't end, they become remnants. Matter doesn't vanish, it rearranges. Energy doesn't disappear. It spreads. Time doesn't stop suddenly. It fades as change fades. At every level, we don't see absolute endings, we see transitions. Now here's the deeper mini-hook. What if the universe is less like a story and more like a process that never fully stops changing? Think of a fire. It burns brightly at first. Flames, heat, light. Then it dims. The flames disappear, but the energy doesn't vanish. It spreads into the air, into the surroundings. Eventually, you can't even tell the fire was there, but its energy is still part of the system. Now scale that up. The entire universe is like that fire, bright at first, active, full of structure, then slowly, quietly, it spreads out. Not gone, just different. Now here's the important shift. We tend to value things based on how long they last. But physics doesn't work that way. In physics, what matters is not permanence, it's transformation. Now bring this back to the present. Right now, you are living in the most active phase of the universe. Stars are shining, energy is flowing, structure is everywhere. This is not the default state. It's a temporary window, a rare phase, and that changes how we see it. Because instead of thinking this will all end, we can think this is a brief moment where the universe is incredibly alive. Now, here's the next mini-hook. What if the value of the universe is not in how long it lasts, but in what happens while it is active? Think about anything meaningful in your life, a conversation, a memory, a moment. None of them last forever, but that doesn't make them meaningless. It makes them real. Now, apply that to the universe, the age of stars, the emergence of life, the rise of awareness. These are not diminished by the fact that they don't last forever. They are defined by it, because without change, without limits, nothing would happen at all. Now let's go deeper. We've talked about entropy, the gradual spreading of energy. It sounds like decay, but it's also what allows processes to occur. Without energy differences, nothing moves, nothing changes, which means the very thing that leads to the universe's quiet future is also what makes everything possible now. Now, here's the deeper mini-hook. What if the ending of the universe is not a failure, but the natural consequence of everything that made it interesting in the first place? The same laws that allow stars to shine also ensure they will fade. The same processes that create complexity also lead to its dissolution. It's not one or the other, it's both. Now step back. The universe is not trying to preserve itself. It's not aiming for a final state. It's not heading toward anything in a purposeful sense. It simply follows its laws, and those laws produce a sequence of phases, each with its own properties, each with its own possibilities. Now bring it back to awareness. We said that awareness is temporary, that it emerges and eventually fades. But that doesn't make it insignificant. It makes it rare, and rarity gives it weight. Because in the vast timeline of the universe, there are long stretches where nothing complex exists, no observers, no questions, no understanding. And then, for a brief window, there is. Now here's the next mini-hook. What if this moment, right now, is one of the rare moments where the universe is capable of understanding itself? Not forever, but now. And that makes it different. Now let's connect everything. The universe evolves. It creates structure. That structure allows awareness. Awareness creates meaning. And then the conditions fade, but the process remains. Amen. Now here's the key insight. The universe is not meaningful because it lasts forever. It is meaningful because for a time it can experience itself. And that experience is happening here. Now pause, because this is where perspective shifts. Instead of seeing the universe as something that is ending, we can see it as something that has phases. And we are in one of the most extraordinary phases, a phase where energy flows, structure exists, awareness emerges. Now here's the final mini-hook for this part. What if the most important thing about the universe is not its beginning or its end, but the fact that it has moments like this at all, moments of light, moments of thought, moments of understanding? Because those moments are not guaranteed. They are the result of a very specific set of conditions, and those conditions are temporary, which makes them special. Now, take a breath, because we're almost at the end of this journey. We started with a question about the future. What happens after the last star dies? And we followed it through physics, through time, through awareness, through meaning. And what we found was not just an answer about the future, but a new way of seeing the present. In the final part, we're going to bring everything together, not just as an explanation, but as a perspective you can carry with you. Because the story of the universe is not just something you learn, it's something you are part of. And once you see it that way, everything changes. So, what happens after the last star dies? We've traveled through it all. The fading of light, the silence of galaxies, the slow unraveling of matter, the disappearance of time, the transformation of awareness. And now we arrive at the end, or at least what we once thought was the end. Here's the final hook. What if there is no true ending? Only a universe that changes so much it becomes something we no longer recognize. At the far edge of time, or whatever replaces time, there are no stars, no warmth, no familiar structures, just an almost perfect stillness, a universe that has spread itself so thin that nothing noticeable happens, no events, no stories, no observers, and yet it still exists. Not as a place full of activity, but as a quiet state of possibility. Because even in that silence, nothing has truly vanished. Energy is still there. Information is still there. The structure of reality still holds. It has simply changed form beyond recognition. Now pause, because this is the moment where everything comes together. We started with a simple question. What happens after the last star dies? And along the way, that question transformed. it became. What happens to matter? What happens to time? What happens to awareness? What happens to meaning? And now we can finally answer. Matter does not end. It transforms. Energy does not disappear. It spreads. Time does not stop suddenly. It fades as change fades. Awareness does not persist forever. It emerges and eventually dissolves. And meaning exists only while there is something to experience it. Now, here's the deeper realization. The universe does not end in a dramatic collapse. It ends in a quiet absence of change. Not a bang. Not a final moment, just less and less happening until almost nothing does. But even that is not truly nothing. Because as we've seen, possibility remains, tiny fluctuations, rare events, moments that can still emerge in an otherwise silent cosmos. Now let's step back one last time. The universe begins in simplicity. It evolves into complexity. It creates stars, galaxies, life, awareness, and then it slowly returns to simplicity again, not as a cycle we fully understand, but as a transformation from order to complexity, to stillness. And within that process, there is a brief window, a moment where everything aligns, energy flows, structure forms, awareness emerges, and that moment is where we are, right now. Now here's the final quiet question. What do you do when you realize you are inside one of the rare moments where the universe can experience itself, not forever, just now? Because this moment will not last. The stars will fade. The galaxies will drift apart. The universe will grow silent. But right now, it isn't. Right now, there is light, there is structure, there is awareness, there is you. And that means something extraordinary is happening. The universe is not just existing, it is experiencing itself through your thoughts, through your questions, through your curiosity. Now take a breath, because this is the shift. The story of the universe is not just about its beginning or its end. It's about the fact that, for a brief moment, it becomes aware. And that awareness is not separate from the universe. It is part of it. You are part of it. Not outside, looking in, but inside, experiencing it. Now, here's the final mini-hook. If this moment is temporary, does that make it less important or infinitely more valuable? Because it will pass, like everything else, but while it exists, it is real. And that might be the most important thing of all. So the next time you look up at the night sky, remember this: those stars will not shine forever. But right now, they do. And right now, you are here to see them, to think about them, to wonder what comes next. And in doing so, you are part of the universe, understanding itself. That might not last forever, but it doesn't have to, because it is happening now. And that is enough. If this journey made you pause, even for a moment, take a second to like the video, subscribe to the channel for more quiet explorations like this, and let me know in the comments what part of the universe fascinates you the most, because every question you ask is another way the universe continues to explore itself. And if you're ready for the next mystery, there's a deeper question waiting. What existed before the beginning? And could it still exist now? But that is a story for another night.